Welcome to the Construction Brothers Podcast. I'm your host, Tyler Campbell, and with me, like he is every week, my brother, Eddie Campbell.
What's up, Tyler?
Not much, Eddie. Well, this week, Delegated Design Deep Dive. Dude, I'm gonna shake off the cobwebs.
For real.
Our editors left for like a month. I don't know if you guys, we didn't talk about this before it happened, but they left for the Cannes Film Festival. Cannes? The film festival over there in France, and they were gone for a month. And so now I'm all out of whack here. I forgot, what is this thing? What is this thing in front of me? So anyway,
Yeah.
a lot has transpired.
Not having the headphones on is kind of throwing me off too.
Yeah, a little bit. I get that. Dude, a lot has transpired though over the past month.
Yes, it has. You wanna share anything?
No, I'm good. I'm good. Nothing
There is
happened.
a story that we cannot avoid here that has to be told.
I do not recall. I don't recall. What story are you referring to?
There was an ER visit involved. See if that jogs your memory. How many ER visits have you had in the last month?
One.
Okay, let's talk about that one. Let's talk about the ER visit. Everybody.
All right. Okay. All right. I'll fess up. You fessed up a couple weeks ago. I'll fess up. All right.
Fair.
So, and I apologize to anybody listening to this that has heard me tell this story probably 50 times. I'm so sorry. I'm not that much of a narcissist. That much. So anyway, I'm still going to tell it. Just fast forward if you don't want to hear it again. Anyway, so yeah, I took a nice little trip to the ER. Started playing church league softball this past month. Dude, softball is a ton of fun.
Yes.
All right?
Mm-hmm.
I've enjoyed it. You've been playing.
Absolutely.
We played against each other once, and then we got rained out last night, which I'm still mad about, dude. I'm still mad that we got rained out.
The teams were going head to head.
We're going to go head to head, and we were starting to hit our stride, all right? Anyway, so church league softball, we're out practicing early on a Saturday morning, and, we called an early practice for some reason. I cannot remember why, but we're out there at around 8:30. That's pretty early, and for a Saturday at least. So I skip breakfast, as you do.
Mistake number one.
So I skip breakfast. And I don't know if you know much about Milledgeville, Georgia, but I'll clue you guys in on something. It's a little humid and hot here. So I was sweating a pretty good bit too, which means that I was dehydrated. I definitely should have been drinking more water.
You drank what instead?
Huh?
What did you drink all morning?
Coffee.
Of course you did.
I had 2 cups of coffee, no water, or not enough water.
Another mistake. Okay. Yeah.
Yeah. Anyway, so we're out practicing and stuff. I'm up at bat, and we're doing some nice batting practice. And on the last one, we're hitting and we're running, right? And so I hit the ball, grounds out to shortstop, and he goes to throw me out. And I was like, oh, heck nah. And so I hit the NOS button on my butt, and I hustled down the line. I got to the bag before the ball did, though.
Okay.
So, hey, at least we got that going for us.
Yeah, way to beat it out.
I beat it out, baby.
That's a single, bro.
I beat it out.
Then it beat you out.
And then I tripped on the bag. My feet got all sorts of tangled up. It's all sorts of weird gyrations through the air. Ultimately, pancaking myself down on the ground on this nice compact dirt because it's a crappy field, Anyway, so I land on my side. When I land, I hear something pop, and I knock the wind out of myself.
Right.
Now, all right, for those of you that haven't watched the video or seen me on video, let me clue you in on something. I'm 6'2", 260 pounds, not north of that some days, not at all. Anyway, so I pancake. When I pancake, there's slight fracture in the Earth's core. I'm not small, all right? So I rattle myself real good.
Yep.
I lay down there for probably a minute or so. I'm kind of just catching my breath, trying to shake it off. I finally stand up and I walk back over to the dugout. Whole time I'm walking over to the dugout though, man, I'm just feeling a little bit off, like feeling a little lightheaded and stuff. And I kind of notice like curtains are kind of coming in, that sort of thing. And I'm like, all right, well, I'm gonna keep walking, I'm gonna keep kind of moving and stuff. Well,
no, you're done.
I finally felt a little more sleepy, and so I started sitting down. And that's not what you're supposed to do, FYI. Elevate your legs, everybody. Learn from my mistakes. Anyway, so I sit down, and I'm kind of fighting the curtains at this point, right? I'm like trying to drink some water, trying to just, breathe and like deep breaths, that sort of thing. Yeah, that didn't last. So 45 seconds later, I wake up on my back with everybody around me freaking out. And I'm like, what just happened? They were like, bro, you passed out. I'm like, whoa. Oh, okay. I'm good. I'm like talking to them, and they're like, bless my church family. They were all around me. They were all concerned. Annie, she calls the ambulance over, and like, so I hear the ambulance off in the distance. I'm like, thinking it's for somebody else until it gets closer. And then I was like, shoot. Crap, not for me. No, I'm fine. They show up. They clip the little O2 sensor on me. And, EMT, he's like, your O2 is just a little bit low. It should have come up by now. And I was just like, I'm feeling all right. I'm doing okay. I'm eating some chicken minis that I stole from a kid. At this point, sorry, Arlo. Anyway, so I'm eating some chicken minis, and just kind of recovering and stuff. And the EMT turns around to his buddy, who's like, "Listen, he says he doesn't want to go. He says he's feeling all right. He says he doesn't want to go. I can't force him or anything like that." And he's like, "You sure?" And I'm like, "Yeah, I'm fine, man." As soon as I say that, my eyes start rolling back. And all I know is that EMT, he has such soft hands, and he caught my head and he cradled me like a little babe. No, I'm just kidding. He's kind of like holding me up, and everybody's like, whoa. I didn't fully go out that time, but I was still passing out. And so I was like, on second thought, let's get on the gurney. And so I'm on a gurney, and I'm feeling not great. Anyway, so yeah. That's pretty much it. Getting the ambulance, hooked me up to an IV for the first time. Never have had an IV, never been in an ambulance, hospital trip, nothing like that. Yeah, guys, the moral of the story is stay hydrated and eat something in the morning. Don't do intermittent fasting on the mornings where you're going to be putting yourself under strenuous activities, such as church league, softball.
Which doesn't sound like strenuous activity.
Anyway, doctor checked me out. I'm fine. I'm good. I got
all good.
Clean bill of health.
Ribs good.
Just a little pride is bruised. It still kind of hurts. It's a little tender.
Yeah.
They did an X-ray on it. No fractures. No nothing. I'm just beat up a little bit. So yeah, that's that. There you go. There's your 20-minute story on how I went to the ER. You're welcome.
I can laugh now. Morning of when I got the call from Sam.
Sam's freaking out. Bless my wife.
She was calm. No, when she called in, when she called me,
she was putting on a brave face is what she was doing.
She was.
Yeah.
She was putting on a brave face. She made sure to not do the Michael Scott and start out with something that sounds disastrous.
Doctors tried the best that they could, and ultimately he's going to be fine. He's going to be okay.
What is wrong with you? Yeah. So she didn't do that.
No,
she made sure she led with, he's okay.
She did good.
And did, keep calm, cool, and collected. And, it worked. And I didn't completely freak out. But there was a little part of me that was honestly a little worried.
Yeah, fair enough.
When you don't hear every day, hey, your brother's in an ambulance on the way to the ER. So when I heard that, I was like, oh, man, okay, here we go. So there was some panic, for sure.
So,
but, glad you're okay, man.
I'm glad I'm okay too. I'm really happy that my wife didn't kill me after that. Survived both things, the ER and the trip home. It's really the things that matter most.
What were you thinking?
Yeah. But anyway, I don't know. I think ultimately it was really cool to see, like real talk. Like, it was really cool to see how quickly friends just kind of like popped into action. Like we've got a really good community of people here around us. Obviously we have family here too, but like it was just really cool to see how fast everybody just sprung into action on that, and like was there to watch our kids. Like showed up, had our backs, and everybody's kind of praying and like making sure like, hey, do you need food? Do you need anything? Like just checking on us. I had people checking on me well into the next day.
Yep.
So I don't know. It's just kind of subtle reminders of like, hey, you're here, you're loved, and it's just kind of cool. So I don't know. I take it for what it is. It sucks. I don't like the medical bills. That's for sure.
Yeah, those have arrived now.
Oh God. I had a buddy of mine who's complaining. He was like, I had to buy everybody's jerseys. Nobody's paying back. And I'm like, you shut your face. You shut your mouth. All right. You hadn't spent anything on softball, sir. You hadn't spent nothing. Nothing. You shut your face. Freaking $3,000 in the hole. Anyway.
Well,
so
moving on, I guess.
Delegated design, anybody? No, we've been kind of kicking around this idea a little bit lately of, talking more in depth about delegated design, what all that means. We've done a 5-minute on it and we kind of glazed over it, but really doing a little bit of a deep dive into what that means, especially for the like GCs who don't really know. We can definitely speak from a steel detailing standpoint on this, from an engineering standpoint, somewhat how it all works together and why it might matter for your job.
Yeah.
And how it affects your job. So when you see delegated design, a little bit more about what that means.
Right.
That is helpful. All right.
Yeah.
So Eddie, kick us off. I'm going to defer to you because you're the resident person who has done this longer than me. So, or done detailing longer than me. I quit. So I'm done. I don't know anything about this now. So what is delegated design, Eddie?
Don't
Your
care
turn.
and don't know why we're talking about this right now. So we're gonna nerd out. Prepare to nerd.
Okay.
And I'm gonna speak about this from a structural standpoint. This is something that we see in steel a lot.
Yeah.
Is the delegation of the engineering of connections and stair and rail components that some would think would be a part of what the structural engineer does as their base offering, but that's not necessarily true. Now, I'm going to speak about it from that context, but that doesn't mean that there aren't other things that are delegated. So like a curtain wall system is not something that would be designed by your structural engineer or your architect. They would kick that design over the fence to an expert in curtain wall design, a curtain wall company, and they would design their system and then present the engineering for review to the design team.
What's important to note is like we're talking through the pitfalls of it too.
Right.
Like as it kind of works through the chain of people, how does it fall apart? How does it kind of break down? What are things that you need to know and where can it get bogged down?
Yeah, where does this impact you? Where does this impact your project? Where does this impact construction that we see? Because we see a lot of projects turn over. And we've seen
schedule. That's the
we've
big
seen
one.
it have a huge scheduling impact. We've seen it have monetary impact. I think you need to be prepared for that monetary impact and know it exists. And if you're buying design, I'll say if you are a design builder and you are buying design, this is absolutely something you need to know because two engineering bids might not be the same scope at all.
Yeah.
One may be planning to complete the connection engineering and one may not. They both may have solid reasons for doing that, but you need to know what you're getting. And you need to make that decision on purpose. So
why is this engineer's drawings $20,000 less than this other guy's over here? It's because they've deferred all of their design, all of their connections at least, over to another entity. Now that other entity that you don't know could potentially gouge you. Could, not all the time, could. But I mean, typically when you break stuff up, yeah, there's margins in that you got to watch out for.
So what is delegated design? Delegated design is the process whereby say the SEOR, the structural engineer of record on a project would say, I am going to limit the scope of the things that I am designing to things that are not connection components. And so that can be done in different ways, because a structural engineer could say, I'm going to design these connections, like maybe something that's complex or something that they really care about. I'm going to focus my energy and attention on these things and make sure there's a design there, but on like simple shear connections, like basic beam to beam connections or a basic connection of a beam to a column, I'm not going to really enter my opinions there. I want somebody else to give me what they want to do there. And so they would defer that. They would not cover that. And there would be an expectation of additional services to be rendered by the fabricator that would be in charge and awarded the project. That would be then a part of their scope.
Yep.
So you're going to read this. Like when you go digging around, a lot of times when I look at a project, first thing I'm going to look at is a structural notes sheet, and I'm going to look at the specifications. When I get into the structural notes sheet, I'm going to look for there may be a paradigm of what is going to be submitted as a delegated or deferred design that's going to require signing and sealing, or there may be a note stating that the connections are not fully designed and that I'm supposed to go about designing them in a certain way. So the project's expectations are laid out on that note sheet and in the specifications, and I need to read those. And I frankly need to read them and make sure that they agree, because many times project spec books are written and they don't really consider what the structural engineer of record wanted to do with that part.
Yeah.
So assumptions are made, and there may be differing requirements. So you need to clarify that. So that's where you're going to find it. That's where you're going to go looking for it, and you're going to be able to see, I have additional design work to do. Like I've got more engineering to do to get to where I need to be.
Yeah, that's a pretty important piece of information to know.
Yeah.
I mean, that impacts your schedule. Like if I'm a project manager for a GC or anything like that, and I'm submitting this through to my steel fabricator, and my steel fabricator has to go through this, process of doing delegated design, getting an engineer on board and all that. So that is time. Okay, that's time, and that's something you need to take into consideration. What are the pros and cons of that? Like, can we start with maybe some pros of delegated design? Like, what are some benefits of this? Why do people choose to do delegated design over just owning the whole thing and doing it all from just start to finish?
Yeah, I mean, I would say one of the main things you're going to hear is, I don't get paid enough fee. I mean, honestly, like we can't command the fee that's necessary to do that as a part of what we do. I've heard that a good bit. Another one I've heard a good bit is, I don't really know what the fabricators want to do with the connections. So, if I chuck something over the fence and say connect it like this, then they've got a different opinion. And they immediately say, well, I mean, I don't want to connect it like that. And so they basically scrap everything I do, and they come back to me and say, well, can I do it this way? And then my answer is, I mean, you can if you engineer it and prove that it works.
Yeah.
And they say, okay. So you're back there anyway?
Yeah.
Because the fabricator wants to do things the way they prefer to do them. And maybe as an engineer, I don't have a preference over how a beam connects to a beam.
Right.
If it's coming out of a basic AISC connection that I could pull from the steel manual.
Something to note too for those that don't know is steel shops, steel fabricators, a lot of times they're set up for specific types of connections more than others. Some can be set up for both. Like some are set up to run double clip angles, right? So we're going to have two angles on either side of the beam, right? And that's how they're connecting into other members, right? Other shops are set up to do a ton of welding, and they'll have shear plates. So literally just a plate that's welded on, and then you bolt through it, and that's how you connect beam to beam, column to beam, however, right? Certain shops are set up different ways. And so delegated design basically says, we don't care which one you use. Like, you design what you like, what you think works best for your shop and your operations, so that you can do this quicker. Yeah. So I think they're coming from it from a standpoint of, hey, there could be some time savings here because they're used to doing it a certain way, and we can just let them do that.
Time savings, and then also hopefully assumptions made in the bid that I can work as efficiently as possible. Mm-hmm. And I want to lay out maybe in brief an outline of what AISC in their code of standard practice says are 3 different ways of going about this.
Yeah.
And we'll go 3, 2, 1.
Okay.
The third option is the delegated design option that we're talking about and that we've already outlined. Option number 2 that's laid out in the code of standard practice is that an engineer would give the basic criteria for connections and then would put it on what would be a qualified structural detailer or steel detailer to go and select connections from the AISC manual.
Yeah.
We call it the steel Bible sometimes, but the AISC puts out their steel manual. And in that steel manual, there are pre-qualified connections. There are connection tables. There are things that you can take from that. And if, as a detailer, you know how to read the tables, you can extract that information, you can apply it to how to connect an end of a beam, and it's already borne out like what will happen, like what's engineered for that.
Here's your loads, here are all these other things that you can pull from it.
Right.
So like this end has 35 kips on it. You're using an 18 by 35, that's connecting. You need this many bolts. Here's the type of weld.
Correct.
Like all of that stuff is borne out in the AISC manual for the most part.
So a detailer could select it from the manual. So that's option number 2. Option number 1 is that you design them complete. Okay, so the engineer of record says, nope, the connections are mine along with the structure, and I'm going to design them complete. What we have seen is that option number 3, delegated design of connections, is very prevalent in the East.
Yep.
That option number 1, where the SEOR, the structural engineer of record, designs 100% and provides all of the connection information, is more prevalent on the West Coast.
Why is that?
Maybe some of it is just practice. Maybe some of it is fee structure, but I think some of it is also maybe just the seismic regions that are out west.
More earthquakes out west. Right?
Yeah,
No,
I mean,
say more, but like, yeah.
You get into a design category D job, like a heavy seismic job, then yes, you're going to have a lot more likelihood that the engineer is going to care.
And that comes with its own set of struggles, we'll say, too.
Right. Well, and they are designing, like, connections are a huge consideration in, basically the lateral frames of those jobs. They're set up for very specific things. So once you've accomplished that, because brace connections are kind of like maybe the harder parts of delegated design. Brace and moment connections are the harder part. Like gravity connections, like simple shear stuff is not as hard.
Axials
and so it's
can
like
be pretty weird.
Axial could be weird, but like when you're considering here's real nerdy stuff. So let's say I've got a seismic moment frame, and that seismic moment frame is becoming kind of lay terms, like not an engineer, disclaimer, but
not engineers here.
A collection point for seismic load.
Yes,
the seismic load is traveling through this frame down to the ground, and that travels out into the structure, into the diaphragm of the structure. I might use what could be called an axial or drag type connection to allow that load to be dragged or travel axially through the neighboring beams. It would be very common practice to see that. You might see axial connections. Those axial connections are also going to be a part and a consideration of the seismic, right? That might happen in a moment frame or a brace frame approach.
Yeah.
So, again, kind of uber nerd stuff there, but when it comes down to it, you got these three approaches. You see approach number one, I said, full design, happening more on the West Coast. Approach number three, which is no design of connections, delegate them in their totality. That happens more on the East. And then the middle road, which is have a detailer select it, which I would say is a dying option. Mm-hmm. You see far less of this. To just say the detailer can just select those, or the fabricator can select those from the tables. Most engineers are going to dive at the opportunity to go ahead and have another signatory engineer
Have a peer review of this.
Yeah,
stuff,
sign and seal a set of calculations and connection tables that have been developed
Makes
for the
sense.
project.
It mitigates their risk.
Mitigates some risk,
Yeah.
and also ensures that they've got somebody who actually is looking at all of the criteria, may not like miss, looking at, block shear or something random in the tables.
Okay.
So
Yeah.
option one or three are the prevalent ones, depending on the geography of your project. And what you need to be aware of is that through the general notes, you can usually just, draw out and understand what the engineer wants. Usually. There are some that leave that obscure. And so many times in our pre-detailing meetings, that's one of the first questions we ask. Or maybe we make statements about. I understand that you do or do not want me to perform connection design or hire a connection designer for, providing sign and sealed calculations. Mm-hmm. I do or do not understand that you want me to provide a set of sign and sealed shop drawings, which is a whole another level. Because now if I go get a third-party engineer to sign and seal my shop drawings, they're owning everything on those sheets. And that, from a liability of an engineer, becomes this whole thing too. Some projects require that the shop drawings be done under the direct supervision of an engineer. Mm-hmm. That's a whole other level. How am I going to achieve that? So we've got to be careful, because each one of these things adds time and complexity and cost to your project. Yep. And if you have an engineer that is requiring that, you might think you're going to lean on them or say, well, I excluded that. It's a part of the CDs. Mm-hmm. Okay. So you've got to get that in the formal project record in order to exclude that. And you also need to understand you might be up against the headwind of their insurance provider who said, no, Mr. Engineer, I want you to delegate your connection design on this. It's just something that we prefer you do.
Yeah. All right. So let's really dig into some of the pitfalls here.
Okay.
Right? Like some of the issues that arise with delegated design. One of the ones that I'll mention, that like from just like a structure standpoint and working through projects standpoint, less about the actual like calculations and all that other crap that has to happen. There are more cooks in the kitchen when you do this. And also potentially more room for arrogance to enter the picture. All right. One engineer is very headstrong, we'll say, over their opinion. And sometimes two of those meet and it can get combustible, and it can devolve into your project getting delayed. Right? Now, that is more of a personality sort of thing that you might have to navigate in this, but it's something to be aware of, because I feel like more often than not, that's the kind of crap that can break a schedule, is when you just get two parties in a room that don't really G-haul together, and that can become a problem for you and your entire team.
Yeah, it can become a problem, and depending on the cooperativeness of both parties, you as a general contractor or even you as a steel fabricator could just flat be stuck in the middle watching a tug of war you have no control over. Mm-hmm. You've got a structural engineer that's asking for one thing, and then you've got a connection design engineer and maybe a detailer standing in between that are asking for and or demanding another scenario.
For various reasons.
Okay, here's a scenario in delegated design. Names and geographies
redacted
will somewhat be changed to protect the guilty.
Somewhat.
So working a job, and this is a dime a dozen, honestly. Like we've had this experience on multiple occasions, but delegated design is required on a project. You have the pre-detailing meeting. Hey, do you want us to design these? Hey, we're going to go through these general criteria. Yeah, we think we've got an understanding, and everything kind of gets left on the table as, yeah, I mean, I think everything is pretty understood. The detailer, which is us, we're getting the design done, the connection design done through a third-party engineering firm. That third-party engineering firm delivers to us. We detail out everything. Everything looks about like what we think it's supposed to look like, and then the calculations go over the table along with shop drawings for review or an approval process, however you like saying that. It's a review process. They don't approve it. So they're reviewing the documents and they're reviewing the calculations, and they see things. And in this particular project, we're in a hurricane zone. Okay, and it's kind of the job's configured somewhat like a tower. There's a lot of glass. There's just some weird considerations with it. And I know there are at least a couple listeners right now that are like, oh, remember that?
I know which one it is.
So
I was there for it.
What happens is these go over, and the architect objects to the size of the gusset plates. The architect
on the bracing members.
On the bracing members.
Those plates
members are coming in, and the gussets are creating too much obstruction into the aesthetics of the building. So now, mind you, there's a bunch of people that have done a bunch of work on this just to get to this point.
Yep.
And so as it goes up the chain, it goes through review, and the comment gets made. The comment that's made is make the braces smaller, like basically make the brace gussets smaller. And somehow it seems that the relationship with the architect and the engineer is such that, the engineer's working for the architect. He's one of his consultants at this point. And so, we've all got our loyalties to the person we're working for. And so the engineer's like, yeah, you need to make them smaller. Now the loads on, a kind of a tower frame job in a hurricane zone are not small. And it takes a certain amount of gusset and a certain amount of weld to get that accomplished.
Hold it down.
To achieve the values given, 250 plus kip load.
Which is a lot.
250,000 pounds of pull and push going on a plate, it requires a substantial plate. And so the argument ensues. And really boiling it all down, it wasn't that we weren't willing to change. It wasn't that we weren't willing to meet the architect's aesthetic or that we didn't want to be sensitive to that. What we were asking for was the due time and money to change on the basis of what was a Monday morning quarterback, because the criteria for what was considered, air quotes, big, too big, was nowhere to be found in the contract documents.
Yeah.
Now, had the architect or engineer laid out somewhere that said, you're going to make these connections work, and those gussets will be no more than 24 by 24.
Don't go past this line.
Whatever it is. And that wasn't the actual size of the plate. Then we would have known. Oh, we went over the line. We can do that. We're going to have to come back and look at it. We might have to feed back to them and say, we can't make it work or whatever, and get that on the front end. But that wasn't there. So what created the difficulty was us not knowing the expectation. And so there is still a measure of intent that needs to be conveyed by the structural engineer or architect record to make sure that the people that are taking this design know from the outset that I've got to meet these criteria, but I don't get to just freewheel and do that however I see fit. You haven't just given me carte blanche and said, hey, I don't care. You've said, I want you to work this out, but here are your bumpers. Like, I'm giving you guardrails. I don't want you over here. I don't want you over there. You got to stay within these guardrails, and you got to work the problem from there. Now I understand my scope. Now I understand my problem. Now I can go work that thing out. And now I can submit back to you and say, I need an RFI on whatever I can't understand, can't work out, or can't do. That just wasn't laid out well at the front. So if you're going to do delegated design on the front end of the project, and I will say that AISC in their Code of Standard Practice has a good set of commentaries on each one of these options that you can go read, and it gives you an idea of like some good processes to engage in to try to mitigate that job stopping. We didn't know that. You know, oh my gosh, you didn't tell us. And how could we have reasonably known that? Because honestly, if you haven't told your connection designer what to do on the front end, and then you demand them to change all of their work on the back end, they are by all rights due time and money to do that.
Yep.
You can't just change the rules in the middle of the game. And that's essentially what's happening. If you do change the rules in the middle of the game, you just have to know, as the rules change, I'm going to have to make sure that the guy that's here agrees to the rules and will continue to play the game with me.
It's ridiculous the number of times where that happens, where the game gets changed and there's no acknowledgement of that fact by people that do this, right? Like an engineer should by default know if we're making these gussets smaller, that is going to have a ripple effect. An architect should know if we make these smaller, it should have a ripple effect into everything that they have done, and they're going to have to rework this.
Yeah.
But there is a lot of times no acknowledgement of that fact. None. And then they're just like, well, what? Like, this is part of your job. Okay, yeah, getting kicked in the teeth, yeah, sure, that's part of my job.
Well, so why do we want to talk to you about something that's this like granular and nerdy? Why would we get into the weeds of all of this? Why does it matter? The reason it matters is because when we get into projects and this happens, there's a lot of misunderstanding. Okay. And we're trying to get this misunderstanding kind of unearthed because we've seen it stop projects. Yes?
Yeah.
I mean, hold
Big
projects
time.
hostage for 6
Months.
weeks, 2 months,
Yeah.
3 months. And most of what makes it stop, I mean, some of it may be inattention, but most of what makes it stop is just not understanding how to make it go again. Not understanding how we're going to get the parties to talk to one another sufficiently and say what needs to be said to make the thing move. And so many times general contractors get themselves in a spot where they go, I don't understand the problem. And so voices begin to raise and the temperature begins to go up. And people start talking about liquidated damages and dirty words like that.
Right.
And it's like, it gets really ugly. Because the GC, and I don't know how many times I've heard this one in the meeting, well, I just want my steel. And their insert word in between my and steel, however you see fit. I just want my steel.
Gosh darn.
Now, can you really do that? Because the word between my and steel that is actually holding you back is not an F word. It's actually coordination. I just want my coordinated steel. And guess what, Mr. GC? You're the coordinating entity.
Yeah.
So you can't just stand there with no understanding of the process and point at two different people and say, it's their problem.
You're the
and
ref.
a lot of times what will happen is you're going to pick a side. You're going to pick a friend and you're going to go with one or the other based on who you think the bad guy is. If you lack understanding about this thing, you might not pick the right good guy. And you're going to find yourself in a spot. You're not going to get that log jam released in time for it to not have a very negative impact on your project. So what can we do? What can we do to kind of overcome and thwart a lot of this? Do I recommend that every job always gets 100% connection design? I don't know that I can really say that. I mean, in a starry-eyed, dreamy world where I could get a set of documents that I was able to feed back on up front and just say, yeah, I want connections that look like this. Maybe that works. But I can tell you, I've been a part of designs where I did dictate the connections, and I said, I think we should use shear tabs on this. Like I can think of a specific job right now where I said, I want shear tabs. And we went out and we bid it, and the lowest bid came back, and they were good low, qualified sub, good fabricator, but then they came back with the, if you could flip this to double clip angles, we'd save you another $15,000. Now, why? I don't know. Was it perception? Maybe. We've run into that. We've run into fabricators that just perceive that a certain thing is better because it's just always been that way, and that's what they do.
That's what we always have done.
Yeah.
Yep.
So that happens. And that might just be a bid metric they've got on a bid sheet.
Yep.
But either way, they were willing to chuck $15,000 back. Now, my answer to that is, okay, cool. Give me a few weeks, hand me $5,000, and I will change this whole thing up. And I will flip the switches. And then, I'll take 5, the owner gets 10. We can split savings, and I'm not coming out of this after making a call. I do believe that when you come back and change design, the designer should be due some sort of fee to help in that change because I'm exercising preference. Or I have the burden of bearing that out through engineering that it's acceptable to you. I do agree with that. I do also believe that when we start flipping switches at the last moment and changing the design up, that there's time attached to that. The hope is that what I'm doing is going to later save time too. Or maybe that I've just got that time to bury in the schedule right now because I'm in, some sort of float time. The bottom of the whole matter is that we're trying to seek understanding of and what needs to be provided, and we're trying to get that out of the weeds as early as possible. I'm going to take a little note out of Noreen's book here. Like, I'm trying to unearth the risk. I'm trying to unearth my scope risk as early as possible. I'm trying to get out of the weeds all of those scope things that could bite me later as early as I possibly can. And then I have time to react. Yeah. Then I can do something about that.
Yeah.
And connection design is one of those where good communication early can make a lot of difference. Though there are just times when, man, this can really run off the rails. I mean, we've had reasonable objections where, there's a thing in the steel industry called a slip critical connection. Slip critical connections don't allow certain things to take place, particularly oversizing of holes, which there are nuances.
Just said a curse word in front of me. I'll have you know.
Okay, so there are nuances to this, but I remember another project where we had a slip critical requirement where there was no oversizing or slotting of holes allowed, and that included the hard connection of beams to concrete shear walls. So beams to embeds, no slots, which means a concrete guy can go out there and install totally within tolerance, and a steel erector can go out and install 100% within the tolerance, and the member won't fit. Whose fault? Fabricator did everything within their tolerances. Concrete guy did everything within their tolerances. The engineer disallowed any tolerance. Who's at fault? And it got RFI'd at the beginning, and they said, you know what? No, you're not going to change it. And what's really interesting is I know for fact that connection, it got messed with. I'll just say it got messed with in some way. I don't know how, but that one was a make or work situation. So
usually a welder is around.
Torches and welds and different things.
Torches and welds. This is what we know.
So the thing that we're trying to get out is just an understanding about the fact that there are a lot of little things like this in design documents.
Oh yeah.
And it's insane how many times, even from a subcontractor who has studied a set of design docs and said, "Oh man, this job is clean.
Mm-hmm.
This job is clean. This job is clean." But there are just some things that are subsurface that didn't really get coordinated all that well that are waiting to bite.
Yeah. Yeah.
And that job ain't nearly as clean as you think it is.
I'm not superstitious, but I am a little stitious, in the words of Michael Scott. Yeah, don't say this
Don't
job
say
is
that.
clean. That's just don't do it. Just don't do it.
It's asking for it.
It is asking for it. And what's funny is that this one little component that we've talked about for a while here, one little component is comprised of maybe a couple sentences on the specs.
Yeah, this is a paragraph at best.
Couple sentences.
Maybe in the specs, probably in your structural note sheet,
Yeah.
but
This is why we harp on the detail stuff, guys. Like, because if something that small can have this much of a ripple effect on a project, like what else is out there? I know there are other things out there that have ripple effects like this.
well,
This is one facet of the steel industry. Think about the entire project. And it's I mean, that's kind of why construction's fun, though, if you think about it. It's like there's always a learning process that's associated with it. You're always learning something new. You're always getting better at something. You're always figuring something else out. Like it's fun because of that. But it's also terrifying that those 3 little sentences can absolutely wreck you and your life
And
for
have value.
months.
I do want to go into that for just a minute.
Okay.
No, like you're making a great point that
Oh, thank you. I really
I
appreciate
want
that.
to applaud where
Wow.
applaud is due.
Dang. That's
No,
a compliment, guys. Put that in writing.
well, you're right. In that one sentence has a lot of impact.
Yeah.
But I want to put like maybe some actual number on like, because if you're thinking, oh, well, how much could engineering really cost me?
Yeah.
I'm looking at a 1,200 ton structure, $50K. That one paragraph could be a $50,000 paragraph.
Easily.
Yeah.
Easily.
Depending on the complexity of the structure.
And up.
Now
Yeah.
you get a 1,200 ton, very, very simple structure. Maybe not. Maybe it's not that much. You get 1,200 tons of very complex steel. 50 might not even nearly cover it because it's more about the effort that's going to go into it. So if everything's atypical and nothing can be scheduled and the engineer never has done that thing before and everything's got to be done by finite element analysis, now that's a whole lot more money.
What's even more fun too is, all right, let's say this is a 60K line item, and I know for a fact it can go north of that by a lot. It can go up to 200K, like boop, there you go. Delegated design, that's how much it costs.
Yep.
You as a project manager, let's say at a GC as this example, you don't really get a say in who does that. You're spending that money and you get no say in who the engineer is that you're going to have to deal with.
Well, and also
Think about that.
Okay, so here's another little thing that you need to look out for. Your fabricator bids the job, and the fabricator turns that bid in, and then as a line item exclusion in their bid, they exclude engineering.
Yep.
And you look at that and you think, well, that's benign. Of course, they're not engineers. So you kind of read over that. And then we go to launch detailing. And I mean, honestly, like we've worked for fabricators that we've gone back to time and again and said, look out for this spec and cover it. Look out for this spec and cover it. Because we'll ask the estimator, what did you do with this? And they'll go, oh, we excluded it. And it's like, you're not allowed. Like somebody's going to have to cover it.
Yeah.
That engineering is not going to be bought by the general contractor.
Right.
The general contractor is going to expect you. But if they exclude it, that means their bid and scope don't cover that.
Yeah.
Depending on how you've written up your contract, if you've included their scope in the contract, you could have a $50,000 hole in your project based on scope on a line item that looked very benign. So, I mean, if you're buying design, know how much design you're buying. You know what is designed and what is not. What additional, I mean, it's just a simple question maybe of your engineers. What additional engineering is delegated on this project? And get an answer. Or the architect.
That's a real quick one.
When you go to your architect and you try to determine, like, for you and your consultants, what do you typically delegate to a third-party engineer? Or expect a subcontractor to provide engineering on? What line items? And they'll go, oh, we've got this little sheet in our specs, or we've got this little sheet that we put in our notes. They're expected to submit these things fully engineered. And they're going to have curtain walls and stairs and bar joist and deck and things like this. And you go, okay, pretty standard stuff, right? And you're going to have to make a determination like, do I have it covered? So don't let yourself be sitting there flapping in the breeze for $50K that you know you're going to have to pick up that somebody excluded on you. Define it. Define it and make sure that you got it.
Yeah, East Coasters for sure stay frosty on this. West Coasters, I mean, I would say also stay frosty because I'm sure something like that could slip in occasionally. But, I mean, it just shows, the devil's in the details, right? And it's worth taking a little bit of time to read through your specs, read through everything on those first couple pages of your drawings and understand what you're getting yourself into. Oh, yeah. I think rookie mistake that I made when I first started out was not taking the time to read them, one, and then understand them, two. Right? You know, like, and understanding them might take a little more time. I get that. But ask questions. What does that mean? What's this? What's that? Go to somebody that's older than you, ask a question, and if they don't know, okay, no harm, no foul. Let's go figure it out. Like, what is this? It may not have ramifications on the day-to-day, but at least you know. You know, ask questions, be curious. I think that's more important than anything. I
used to, when I'd take a job off, I'd ask for a tonnage and start with a plan and give it a quick cruise and go, okay, that doesn't look too hard. And then I'd kind of get into the sections.
Right, yeah.
And then maybe last I'd read the notes. My process now, when I get a job, I'm looking at the title block and the note sheet first. I want to know who my architect and engineer are. And I want to know whether I've seen them before and whether I had a good experience with them. Then I'm going to read their notes and see what they're requiring of me. I'm also going to read, and I'm going to find out the design criteria. I'm going to read the design criteria, and I'm going to find out what I've got to do from that aspect as well. Then I'll take a quick glance at the plans and then immediately go and start thumbing through details. I want to get down to the details, and I'm going to start working out. Because if I see anything funny, I'm going to chase that funny detail back to where it was in the plan and start opening the job up. I'm going to start looking at it and understanding it more. So it's amazing how that process is reversed, where it's very easy to look at something from kind of a high level view and go, oh, it ain't going to be too bad.
Yep.
And you don't really understand how much time is going to be lost in a specific thing.
Peel the onion, everybody. Oh, yeah. Peel the onion.
Yeah, make sure you know.
It's got layers for sure, and it will make you cry. 9 times out of 10, it will make you cry. Anyway.
Carry that analogy.
All right, Eddie, any final words here? I feel like back into a rhythm again, shaking off the cobwebs. Feels good to be back. Excited to record some new stuff over the next couple weeks. But any last thoughts on this? I feel like we've covered a pretty good range here.
You had a very cheesy analogy. Can I have one?
What, the onion thing?
Yeah.
Okay. Sure. Take it.
Okay. Everybody hear me. Don't let connection design trip you up like first base trip Tyler.
It's not worth the financials. It will cost money. Let me be clear. It's not free. Oh, gosh.
There you are.
All right. Yeah, that wasn't too cheesy. That was pretty good. Okay. This was pretty good. I give you that one. All right, guys. Thanks for joining us this week. Go build something awesome. I'm going to try not to trip again.